Hello friends, this video on atoms part 1 is brought to you by examfear.com. No more fear from exam. Topics to be covered in this lesson are discovery of electron, proton and neutron and their characteristics, Thomson's model of atom, Rutherford's model of atom, atomic spectra, spectral lines, Bohr's theory of atom, Bohr's model of hydrogen atom, and de Broglie's explanation of Bohr's postulate of quantization. So as the name suggests, we are going to talk about atoms. The name is very much familiar with all of you, right? Every time we talk of anything, we talk of matter, we talk of molecules, and therefore we talk of atoms. So now in this lesson, we will exhaustively talk only about atoms. What is an atom? How was an atom discovered? And several other things related to the structure of an atom. How does an atom look like? What does an atom consist of? So this is all which we will talk about in this lesson. Now, if you look at what have we been studying in physics, you would see that we started with, in your very earlier lessons, we talked about electrostatics, electricity, then we came to magnetism, then we tried to relate electricity and magnetism, how both of them are related. Then we gradually proceeded and we spoke about electromagnetic waves. Thereafter, we talked about waves as such. Then we proceeded again and we talked about optics. Thereafter, we talked about the dual nature of matter and radiation. That is, every object which we see in this world can behave as a particle as well as it can behave as a wave. So that is all that we have been progressing so far. So now here in this lesson, we will talk about atoms because it is very much necessary that you should know about atomic structure. What is the structure of an atom, so that it will help you to go further. As I told you that presently what is true is nothing but your quantum physics. The physics which tells that everything which we see around us has dual nature. That is, it has particle nature as well as wave nature. Okay, so let us forget all that and let us start and see what is an atom. So let us start with the very basic definition of an atom. Atom is the basic unit of matter that consists of a dense central nucleus surrounded by a cloud of negatively charged particles. So that is how we have been defining atoms since ages, right? That is how all of us know atom as. What is atom? It is nothing but the basic unit of matter. Whenever we look at any object, it is nothing but matter, right? Matter is made up of molecules and molecules in turn is made up of atoms. So atom is a basic unit of matter. It consists of a nucleus, right? You have, this is the picture of an atom which we have in our mind. This is the nucleus, and then you have the electrons which revolve around the nucleus, right? And the nucleus is dense, it is massive, it has good amount of mass, and the nucleus again consists of the neutron and the proton, right? So that we all know these basic things about atom. Okay, so when we talk about an atom, you can imagine how small an atom would be, because whenever we talk about atom, we talk in terms of units like angstrom or Fermi, which I have mentioned here. And what is 1 angstrom? You all know that 1 angstrom is 10 to the power minus 10 meters. So you can imagine how small it is. It is 10 to the power minus 10 meters, right? Normally when we talk about lengths which are like visible to us, we talk about meters. We talk in terms of meters, centimeters, millimeters. Till then it is fine. But when we talk about the size of atom, we talk in terms of Fermi, which is again, how is Fermi related to angstrom? 1 angstrom is again 10 to the power 5 Fermi, right? So atom is that small. So if you take this as an example, like let us suppose if we assume that a cricket ball represents a nucleus. If the cricket ball is a nucleus, then the radius of the atom would be about 5 kilometers. So you know how much is 5 kilometers? right? It is quite a long distance. So you can imagine this, why this statement has been quoted here, just to ensure or just to show you that how small the nucleus is when compared to the size of the atom. That means if this ball is your nucleus, then your atom is, the radius of the atom is 5 kilometers. That means from here some 5 kilometers, I mean that is beyond the scope of the screen. 5 kilometers is a long distance, right? So that big would be your atom. And when we talk about atom, we anyways know that atom itself is very small. So you can just imagine, or you can just compare the size of the nucleus to that of the atom. So let us now see, why are we studying atom? What is the necessity to study atom? Well, I mean, it is needless to say that everything that we see around us, starting from anything, is nothing but made up of atom, right? Also, when you study atoms, it helps you to understand the various kinds of chemical reactions which take place. I mean, this is the part which will be better taken care of in your chemistry lessons, because there you would have seen, I mean, in your chemistry lessons you would have seen that if you know the atomic structure, if you know the electronic configuration of each element, it helps you to understand the chemical reaction. It is you who is able to say that what will happen if sodium reacts with chlorine, what will happen if hydrogen reacts with oxygen, right? So that means if you are aware of the atomic structure, because only when you understand the atomic structure, only then you can understand how the electrons are distributed in an atom, right? So if you understand that electronic distribution, then you know the electronic configuration of each element. And once you are aware of the electronic configuration, you can understand the various chemical reactions which take place, because everything that happens around us is nothing but different kind of reactions taking place. The tablets which you take, or the medicines, capsules or tablets, whatever you take when you fall ill, what are they? They are also formed by mixing different kinds of substances, right? They all have different composition. So studying atom is a very basic thing. If you know the atomic structure, that can, learning on that, top-ups on that will help you to understand many more things which happens in our day-to-day life. So starting from any small object which you see around yourselves, whether being it an eatable or a ball or a car or whatever, everything is made up of atom. So studying atom is necessary, right? So without wasting any further time, let us quickly look at the history of atom. We will not spend much time on this slide. We will just see how atom was discovered. Long back, somewhere around 500 BC, there was a Greek philosopher, a Greek as well as Indian philosopher named Democritus, who coined the term atom. He named it atom. What is atom? What is the meaning of this term atom? It means indivisible or uncuttable, something which cannot be further divided into smaller parts. However, during that time it was considered that atom is indivisible. You cannot further break it down into smaller components. However, later it was found that an atom is also further divisible. That is, atom also was further consisting of electron, proton and neutron. In fact, even after a couple of years, it was found that even those electron, proton and neutron were also further divisible into smaller particles. So, however, during that time, somewhere around 500 BC, it was assumed that it was known to people that atom is uncuttable. So that is why Democritus named it as atom. In 1805, John Dalton proposed the atomic theory. He proposed a theory where he told that every object is made up of atoms and atoms are indivisible. So whatever John Dalton spoke was on same lines as that of Democritus. Again, after a few years came up Faraday with the cathode ray tube experiment somewhere around 1850s. So what was this cathode ray tube experiment? Again, an evacuated chamber was taken. I mean, I have discussed this experiments and all in our previous lesson, that is dual nature, right, where I told you that if he took an evacuated tube and he saw that there was a cathode and there was an anode, and he saw that some rays were coming up from the cathode, because of which he was able to see some glow. So from these cathode rays tube experiment only later electron was discovered. We have discussed all these things in our previous lesson, so I don't want to waste time again discussing the same things. So again, after a couple of years, as I mentioned, J.J. Thomson discovered electron and concluded that they were a component of every atom. So J.J. Thomson was the one who told that atom was not indivisible. Atom can be further divided, and he was the one who discovered electron with the help of the cathode ray experiment. With that idea in mind, he was able to discover electron, and he also told that electron was a component of atom. So Thomson proposed his own atomic model, because in his atomic model, atom was no more uncuttable. Atom was now consisting of electrons. Thereafter, somewhere around 1909, another scientist named Rutherford came up with a gold foil experiment. So he proposed a completely new atomic model. So J.J. Thomson was the one to propose an atomic model. After that, Rutherford came up with this experiment, which was very successful, and this Rutherford's model of atom is what is very similar to what we know atom today as. Because earlier, whatever the concepts, earlier, long back, people thought atom is indivisible. So at that time, they thought that that is correct. But with passage of time, with more and more efforts put in by different scientists, it was found that no, atom was divisible. Similarly, Thomson gave one atomic model which was considered true at that time. But later, when Rutherford performed his gold foil experiment, he found that a new atomic model which laid the basic of the real structure of atom. So Rutherford's atomic model was a very important concept. Thereafter, in 1912, came up Bohr, who proposed a new model of atom. So, though offering a satisfactory model for explaining the spectra of the hydrogen atom, it could not explain the spectra of multi-electron atoms. I'm sure right now you're not understanding any of these, that what is spectra, what is multi-electron atoms. So in Bohr atom, an electron is considered as a charged particle. Okay. So in first atomic model was given by Thomson. Then Rutherford did one experiment and he told that Thomson's model was not correct. So he gave a new model of atom. However, Rutherford's model of atom was also not completely satisfactory. It could explain many things, but there were many things which it could not explain. So thereafter came up Bohr's model, which could explain the limitations of Rutherford's model. So Bohr's model in that way was better than Rutherford's model. However, Bohr's model also had certain limitations, and those limitations were covered up by the modern or the quantum mechanical model of atom, right? So this is how the atomic structure was discovered. So if you see, it started somewhere around 500 BC when atom was discovered, and then gradually it extended till 1900s. So it took so many years to actually understand that what is the structure of an atom. So even after this, somewhere around 1924, de Broglie hypothesis talked about the dual nature of electron, right? We have spoken about de Broglie's hypothesis in our previous lesson. Yet after this, somewhere around 1926, Schrödinger proposed an equation called Schrödinger equation to describe the electron distribution in space and the allowed energy levels in atoms. So as I told, Bohr's atomic model was quite successful. However, it had certain limitations. So those limitations were covered only by quantum mechanics. What is quantum mechanics? The branch which deals with dual nature of objects. It talks about it says that every object which we see can behave as a particle, it can also behave as a wave depending upon the circumstance under which we are observing that particle, right? So Schrödinger was an eminent scientist in the era of quantum mechanics. So Schrödinger gave an equation which described the electron distribution in an atom. Right? When I talk about atomic structure, what do I want to know in the structure of an atom? We want to know how the electrons are distributed around the atom. I mean, inside the atom we have a central nucleus and we have electrons revolving around the nucleus. But we want to know how those electrons are distributed around the nucleus. That is the most important question, right? So Schrödinger gave one equation which is popularly known as the Schrödinger equation, which tells us how the electrons are distributed in space and what are the allowed energy levels. So we will talk about energy levels, we will talk about electron distribution as we go ahead. Again, in 1927, Heisenberg proposed the Heisenberg uncertainty principle. So if you see this de Broglie, Schrödinger and Heisenberg, they were all talking about dual nature, right? So they all have entered the quantum era. So in reality, what we see, I mean, we don't see actually, but in reality, the atomic structure is nothing but what was proposed by this quantum mechanical model. So this is how you can see that how much time it takes to know what actually the structure of an atom is, right? So again, around 1932, there was another scientist called Chadwick who discovered neutron. So see, something very surprising that for so many years, there were so many studies and investigations going on atoms, but neutron, which was again another component of atom, was discovered after such a long time. Neutron was discovered very recently, somewhere in 1932. So that means neutron was discovered almost around the time when everybody knew that when quantum mechanics had already come into picture. So neutron was discovered after quite a long time.
Thank you. Please visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thank you once again.